This is R.D. Sharma solution, class 12, chapter 18, Maxima and Minima we are taking. The exercise is 18.1. Sin 2x plus 5 on R. So we have to find out the maxima and minima. The first thing comes is sin x and cos x. We know the limitation or the domain and range of sin x. Sin x always, because x value is the domain and sin x is the range. So the range is only -1 to 1. This is the only limit for sin x as well as the cos x. Now this x can be theta, this x can be 2x, this x can be anything. So when we write sin 2x, nothing changes. It still is between -1 and 1 only. So this is the answer. Now in order to match this, we have to match this, right? Because the function is plus 5. So let us add plus 5 on all the different terms you see here with the inequalities. So when you add certain thing and subtract certain thing, the inequality won't change until you multiply or divide by a negative number. The inequality will change only then. So what do you get? Sin 2x plus 5. It lies between 6 and over 5. So the lowest limit of sin 2x plus 5, which is our function fx only, the lowest limit is 4. And the highest limit is 6, that the minimum is a 4 and the maximum is 6. What does it mean? This is the answer. You can just write answer and just let it go. But the better way is to understand using the graph. That is, a simple understanding is this function will only be oscillating, because the sin 2x is a periodic function. It is oscillating. It is an oscillatory function. It will only oscillate between 4 and 6. This is the normal sin x. Sin 0 is 0, so it will pass with 0. But since sin 2x is there will be a difference in the periodicity. Along with you're adding 5. So that is, it will interact with the y-axis at 5. That is, the highest will be 6. If you just mark it by your bare hand and you just mark 4, 5 and 6, this graph is going to cut the y-axis at 5, and this graph is going to be in between 4 and 6. The lowest limit is 4, that is the minima, and the highest limit is 6, which is the maxima. This is the 5 from, this is the line I'm just making in order to show you that what is the sequence or the significance of this graph. Because, knowing the answer is quite easy, but understanding is very important, because you see here, this is the maxima, this is the minima, and as I said, it is going to pass through 5 when sin 2x is equal to 0. The function value is 5. So when will be sin 2x, which is the fx function? The fx function is 0 when y is, we are talking about y-axis. So y-axis, this sin 2x, when it is 0, it will be 5. Then we have sin 4x plus 3 on R. First thing you have to understand about the modulus. The modulus remains the same. It can be sin theta, it can be anything inside the theta. Sin theta will always be between -1 and 1. The range of sin theta and cos theta is always between -1 and 1. It will oscillate between that. When you don't have to worry about what is 4x, because it is sin theta. Theta can be anything. But one thing is clear, it has to be between -1 and 1, which you just have witnessed in the previous question also. Now we have to add 3, because the function is saying such that we add 3 on all the terms which you see in the inequality relationship. So now you add a plus 3 on either side. So -1 plus 3 is 2, 1 plus 3 is 4. You got the limit. You got the minima and maxima, but not, up till now we haven't applied the modulus. But even if you apply modulus to 2 or 4, they are going to give you positive values only. So it doesn't matter whether you apply modulus or not, because the function is lying between 2 and 4. The previous function we just witnessed was between 4 and 6. This is 2 and 4. 2 is the minima, 4 is the maxima. So again, this function sin 4x plus 3 is going to modulate or is going to oscillate only between 2 and 4. And what is the point at which it is going to be 0? Just make sin 4x as 0. You'll get 3. So this function sin 4x plus 3, the lower limit is 2, which you see here also, y equal to 2. So I've made a line which is parallel to x-axis. Again, a line which is parallel to x-axis at 4. This total function is only between that. And when sin 4x equals to 0, it is 3. So you know also now when this function is going to cut the y-axis at 3 between 2 and 4, and there is a value 3 on which this is going to cut the y-axis. So you just have to worry about the lower limit, which is the minima 2, maxima is 4, and the periodicity is also changing, so the graph may vary. Fx equals to 2x cube plus 5. Now I would like you to go along with x, put the various values of x as plus and minus, and then find out the solution. But why you are here? You are here to understand the logic, to understand the tricks. So the trick here is, whenever you have a degree as odd, because x cube, that is 3, x to the power 3, is an odd degree. Whenever you have an odd degree, whatever you put inside x, it is negative, it will give you negative. You put positive, it will give you positive. So just put x equals to 1 and x equal to minus 1, you will see. I'll just give you a very short example. X as 1, 2 into 1 cube plus 5, that is going to be 7. How about negative? 2 into negative 1 whole cube plus 5, negative 1 whole cube is negative, negative 2. 5 minus 2 is 3. So when you put x as positive, it's going to increase. The function is going to increase. But when you put x as a negative 1 or any negative value, it's going to decrease. So it is decreasing and increasing. But you need the maximum and minimum. But since it is ever increasing and ever decreasing, there can't be any point where we can find the minimum and maximum. There is no minimum and maximum. What is the trick? What you have to understand here is, anything to the odd power which will always give you the value which is having no minimum and maximum. X to the power odd is the whole concept here which you have to understand. If it would have been even, we would have done it different. So if you even put, I placed negative 1 and 1, you put negative 2 and 2, you'll see when you put 2, it is going to increase. When you put negative 2, it is going to decrease. So it will increase. This is only the limit of the screen, but it goes beyond that. Lower part also, it goes beyond that. So there is no minimum maximum. It has to settle down to find out minimum maximum, but it is not settling down. It's just going up and down. So just because it is x cube or x raised to the power 5, x raised to the power 7 doesn't matter, because the degree is odd. Minus x plus 1 modulus plus 3. Now the definition of a modulus only indicate one thing. It is a factory. This modulus is a factory or a machine which will always give you positive value. Whatever you put inside, it will always give you the value of greater than or equal to 0. Now multiply both sides by negative 1. I'm not putting anything inside, right? The modulus still remains there, but I'm multiplying both sides by negative. When I multiply both sides by negative, the inequality changes. So greater than or equal to will become less than equal. So when you place less than or equal to, because multiplication means the inequality has to change. Now I'm placing x plus 1, doesn't matter. Now you add 3, because negative is also already multiplied. Now you add 3. When you add 3, the left becomes the function which is under consideration. On the right, it becomes 3. That is, the function remains below 3. So 3 is the highest limit. Alright. Whenever you have certain value which is saying that I am bigger than you, so you are lower than that value. So 3 is the bigger value. The function always remains below 3. So the maximum value is 3. And when you are going to get 3, when this minus modulus x plus 1 is going to be 0, when it is possible when x is equal to minus 1, you place x equals to negative 1. So modulus will always give you positive and negative size also. So you see, I already concluded and told you that this graph, this function is going to be below 3. So the maximum value at x equals to negative 1, because when you put x equals to negative 1, this whole function becomes 0 except 3. So x equals to negative 1, and at x equals to negative 1, which is I'm highlighting on the x-axis also, you're getting y as 3. So this y as 3 is the highest limit. And if you see that below part, this blue line or light blue line, it goes in the negative direction to whichever way it wants. It has no stopping. So there is no minimum value. Maximum value we have y equals to mx p these are actually the lines. So one positive line, one negative line, and we made it, and there is no minimum value. Maximum value is 3, which we found by the discussion we just had. Fx equals to 16x square minus 16x plus 28 on R. This is a quadratic equation. Now the quadratic equation can be solved in a way which we already discussed, that is, we'll make it a perfect square. So we'll try it, and the way I told you, you can just go about solving that thing. 16x square minus 16x plus 28 we have. So we have to get rid of the coefficient of higher limit, which is x square. So you have to take a 16 outside, you get x square minus x. You can keep that 28 aside. You don't worry about 28, we'll just find a solution or the perfect square. It is not 24, it is 28. I'll just change it. Now x square minus x, So how are we going to do this? See, what you have to do is just do one thing. Either make it easier, that is take 1, which is the coefficient of x, divide by 2, square it, 1 by 2 whole square, add it and subtract it, which we already seen. But the better way is to multiply 4 inside. Means 4 4 is 16, so I kept 4 outside and let 4 go inside with multiple. Now you take this negative 4, divide it by 2, which is going to be 2, square it, that is 4, add and subtract 4. So when you add and subtract this 4, is going to be, because there is already a 4 outside, so you cannot add 4 here, you just have to add a 1, because 4 into 1 is 4. But I said when I'm adding by myself this 4, I have to subtract it also. So there are multiple ways of finding the perfect square. It's up to you. I'm telling you an simple way, but it may not be simpler to you. So just I am saying 4x square minus 4x plus 1 is 2x minus 1 whole square. I know that about that. 4 is outside, and 28 minus 4 is 24. Now I hope you got this idea. You can find other way also to find out the perfect. Now one thing is very clear, anything to the power even or anything with degree even will always be greater than or equal to 0. So 2x minus 1 whole square is greater than or equal to 0. Multiply both sides by 4, and you need a 24 also. Just add 24 on both the sides. So 4 into 2x minus 1 whole square plus 24 is greater than or equal to, this is going to be 0, 24 is going to be added, so 24. So this is greater than or equal to 24. So what is this function is always lower than 24. So 24 is the higher one. 24 is saying I am above you. You have to be below me. So 24 is the maximum limit. So the function fx has the highest limit or the greatest limit as 24. This function will, whichever way, if it is being drawn on a Cartesian coordinate system, will always be seen below a line which is 24, y-axis 24, and it will always remain below it. And when are you going to get this 24? When 2x minus 1 equals to 0, because the left one, if 2x minus 1 equals to 0, that is x equals to half, you will get only 24. So this is x equals to half. Now you see the graph solution of this, and there is a slight change in the intervals which are given on the y-axis. It is not like that, because this, as I said, the 24 is the limit of this particular thing. The 24, this function is always greater than 24. As I said previously, if it would have been less than 24, it would have been below 24. But here the function is always greater than 24. So 24 is the lower limit here. 24 is the lowest limit. So this y should be, x should be half, because x, this is the half, I am pointing it here. On the y-axis I am pointing, it has to be 24. So this intervals needs to be changed. But the idea is all about x equals to half, you will get y equals to 24. And this function is going to be above the 24. So 24 is the lower limit, okay? Lower limit, this minimum we know. And maximum we don't know, because it can go beyond whichever point. I can extend the line to whichever way I want, or the curve basically. Now this function you don't have to do anything. You know already that the degree of the function is odd. So you won't get any positive, or I'm saying we are not going to get maximum minimum value anyways. Because x to the power odd, if you give negative, it will give you negative. If you give positive, it will give positive. But x to the power even will always give you positive. So this is, when you put positive, it will always increase x cube minus 1. When you put negative, it will always decrease. So whenever the deciding factor is the even and odd, even means you will get some minimum, you may get some maximum. But for odd power or odd degree, you will not get maximum or minimum. Now you see here, the graph shows by itself. The maximum, if it goes up, there is no limit. The lower limit also, the lower graph also, you see, it goes beyond our comprehension. It goes to whichever way it want, because we don't have any minimum maximum value, just because it is cube. So this is the first exercise we have completed. Thank you so much. Take care.